Hi there. I'm going to go over section 5.1, which is the indefinite integral. So let me pull up those notes for you guys. Sorry, my computer is lagging today. All right, so we have, whoops. All right, so you know that in math, for as long as you've been taking math, you learn about addition and then you learn about subtraction. You learn about multiplication, then you learn about division. You have a function and then you have its inverse, right? The thing that undoes it. So when we have a derivative, it's logical then that we would have something called the antiderivative, or the thing that is like the reverse of the derivative. That's denoted by this capital F letter. So big F is known as the antiderivative of little f. So, for instance, big F is, if big F is this, then the original function is this, because when I take the derivative of this, I get this. So if we go to take the derivative, we would get x squared minus 4x plus 1, and the derivative of 1 is 0. So that is just an example, notation-wise, what big F is. This is going to show that this constant here doesn't matter. So big F could be 1/3 x cubed minus 2x squared plus x minus 100. Or it could be 1/3 x cubed minus 2x squared plus x plus 25. It doesn't matter what this constant is, because when we go to take the derivative, we're still going to get this every time. So this constant is called an arbitrary constant, and we denote that as a little c. Hold on, babe. So this guy, this symbol right here, means the antiderivative or the integral. So that it looks kind of like an S. This is called the integrand. And so we have the integral of little f is equal to big F plus this constant c. So that, again, I used to call him Charlie. Don't forget Charlie. He's important. That's called the integration constant. So let's kind of do some practice here. What's the antiderivative of 2? The antiderivative of 2. Well, the antiderivative of 2 is 2x plus a constant, because what's the derivative of 2x? 2. What's the derivative of any constant? 0. Pi is also just a constant, so the antiderivative would be pi x. E is also a constant, because this is not e to the x. E is 2.7 ... It's just a number. So its antiderivative would be e times x plus some constant c. So this is the rule that if you integrate some constant, it's just the constant times x. Because when you go to take the derivative, remember the derivative is the slope. What is the slope of 2x? 2. What's the slope of pi x? Pi. What's the slope of e times x? E. So if it's just a number, you add an x. This is the most commonly used antiderivative rule. It's the power rule for integrals. And so what you do here is you're going to do the opposite of what we did when we went to take the derivative. So I'm actually going to write out several examples here. What pattern do you see? So we have its function, and then we have its antiderivative. What do you notice? What's happening to the power? Whoops, I did that one wrong. Oh, sorry, y'all. It's been a long day. That should be x cubed over 3. Okay, what do you notice about the power for x? Hopefully you're saying this went up by 1, right? It increased in power, because when you take the derivative, we used to take the power and subtract 1. Now we're doing the exact opposite of that. We're adding 1, and then we're dividing by the new power. So if you're integrating x to the n, it's going to be x to the n plus 1 divided by n plus 1. Or some people write 1 over n plus 1. Okay, so you're increasing the power by 1 and dividing by that power. So I just wanted to let y'all see that pattern there because I think it's powerful to be able to recognize the pattern yourself if you're able. So let's go back to our notes. So what's antiderivative of x squared? It would be x cubed over 3, or 1/3 x cubed. X cubed would be x to the 4th over 4, and x to the negative 4, you're adding 1. So if you add 1, you actually get -3. And so again, all we're doing is we're increasing that power by 1 and dividing by the new power. This rule just says if we have a constant, we can just multiply it times the answer. So essentially the constant just hangs out. So what's my power here? It's actually 1. So the answer is going to be 2x add 1 squared over 2. So then it's just x squared plus c. Don't forget Charlie. Add 1, that's like adding 3 over 3. So that becomes x to the 5/3. Then I still have this 5 in front, and then I'm going to divide by 5/3, which is multiplying by its reciprocal. So that simplifies to be 3x to the 5/3 plus c. If you have a root or a fraction, you rewrite it just like when we were taking the derivative. So this is 2x to the -2, add 1, so 2x to the -1 divided by -1. So we get -2 over x plus c. Summer difference rule just means we can add or subtract the answer. So this is x cubed over 3 plus x squared over 2 plus x to the add 1 -2 over -2 plus c. Now, e to the x, if you remember, the derivative of e to the x was e to the x. So the integral of e to the x is also just e to the x plus c. So the integral of 1 is x, because it would be 1x, plus the integral of e to the x is e to the x. X to the -1 is special. If I went to try to add 1 to this, I would get x to the 0 over 0, which doesn't make sense. So it's actual natural log of x, because remember the derivative of natural log of x is 1 over x. So if we're going backwards, we get that. So that 5 can be pulled out front. So this is just 5, and the antiderivative of 1 over x is natural log of absolute value of x. We do that because you can't take the natural log of a negative number. So here we're going to rewrite this. So this would be x to the 1/2 plus 3x to the -1. And so the integral of that is x add 2 over 2. That would be x to the 3/2 and then 2/3. And then x to the add 1. Oh, it doesn't work when you add 1. So then that means that we need to do natural log. So that is just 3 natural log of x minus e to the x is just e to the x. You can always check by taking the derivative. If I take the derivative of this, I should get that. If you have a fraction, again, you want to rewrite it. So I would just say single on the bottom, separate, and then simplify. So single term on the bottom, separate, and then simplify. This would be t plus 3t to the -2. And then you're going to integrate. So that becomes t squared over 2 plus add 1. So that becomes t to the -1. So then -3. This is the answer for that. And this one, you're going to want to distribute into those. So you can do the power rule. So that would be 10u to the -3 minus u to the 0, because we're going to add the exponents, and then plus u to the -1. Now, u to the 0 is just 1. So the integral of 10u to the -3, you add 1. So it becomes -2 divided by that -2. And then minus the integral of 1 is just u. And then u to the -1, that's 1 over u. And that would be the natural log of u. And then I could simplify that and say -5 u to the -2 minus u plus natural log of u plus c. And then this is just how I can solve for c. So basically, they want me to figure out the particular solution to this. So if I take the antiderivative, they want me to find the original function. I would get 3x cubed over 3, 6x squared over 2. Remember, I'm increasing these powers by 1 and dividing by it. Plus c, don't forget Charlie. So x cubed minus 3x squared plus c is my function. But I can find my particular answer because I know when I plug in 2, the output is supposed to be 4. So we plug in 2 and we solve for c. So 8 minus 4 times 3 is 12, plus c equals 4, so -4 plus c equals 4, so add 4 over, so c must be 8. So that means that our answer then is this guy here, but we're going to put plus 8. The integral of e to the x is e to the x, and the integral of -2x to the first, you add 1 to that power, divide by it, so it just becomes x squared. And then I know when I plug in 0, I'm supposed to get 2. E to the 0 is 1. 0 squared is 0. So subtract 1, so c equals 1. So that means your function is e to the x minus x squared plus, instead of c, I'm going to write 1. Because when I take the derivative of this, I get this, and when I plug in 0, I get 2. And then lastly, I'm going to take the antiderivative of this, and then plus c, and then we're going to plug in 1 and set it equal to, oops, that just cancels, 2. So 1/3 minus 1 plus 3 plus c equals 2. So that's like 3 over 3. So that's -2/3 plus 3 is 9/3. So that is 7/3 plus c equals 6/3. So subtract 7/3. So we get c equals -1/3. So our function would be x cubed over 3 minus x squared plus 3x minus 1/3. When you plug in 1, you should get 2. And so that is the intro to antiderivatives. As always, just attempt your assignment and please reach out if you have any questions.